Good morning, everyone. So today we're going to talk about solving quadratic equations. And we worked on this last year, but here we're going to do a quick review. And there are 4 different methods to solve quadratics. One of them is using a calculator called polysimultaneous, and that's under apps. Polysimultaneous 2 is what most of us have. We could also come along and graph it, and we can use our GDC, or we can use Desmos if we have our computers handy. And then algebraically, without our calculator, we have factoring, and there's 3 different types of factoring. We always start with a common factor, and then we consider this if there's a 1 in front, and then if there's a number in front of the x squared, it has a different approach then as well. And finally, the quadratic formula, which we all know, we've seen the lovely song for. It's equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So those are our 4 different methods. Use the appropriate one for what you have. So here's our first one to consider. I'm going to solve this one. When I see a 1 in front of my x squared, one of the first things I always consider is, will it factor easily? I quickly think of the factors of 10, which are 2 and 5, or 1 and 10. Is there any way to get 4 of those numbers? The answer is no. I'm not going to spend any more time on it, so I'm going to take my calculator straight away and go to polysimultaneous number 4 and hit enter, and I'm going to do a root finder this time. The order is 2, so this is the x squared is the highest power, so it's order 2. Everything else is going to leave the same, so I click on next. And now in front of the x squared I have a 1. In front of the x I have 4. And the constant term is negative 10. Enter and hit solve. And there are indeed my answers there. I get these values. And if I take them, I round them to the 3 significant figures, so negative 5.74. and x is equal to 1.74. That's all I have to do for polysimultaneous. It's quick, it's easy. Let's consider another example like this. Now I have this scenario here. All these decimals, computations, I don't want to do any kind of factoring, any kind of algebra if I can avoid it. So in this particular case, I'm going to go back to my calculator, and it's not set up to use polysimultaneous because it's not in the form ax squared plus bx plus c. So my other approach is I'm going to take my calculator, I'm going to graph it. I'm going to go y equals, and I've already put it into my graph. And since there's no window given, I'm going to start with my standard window. And I graph it. And there I can see what the graph looks like. Oh, come here, graph. And if I want to find these 2 values, I'm going to go to my calculator, go second, trace, and I'm looking for a 0, number 2. And if I do this one here first, I'm going to estimate that it is negative 2. And so it's asking for a left-hand boundary for this scenario. And my left-hand boundary, a little bit left of this, is negative 3. I do not want to go further than the one I'm looking for. So I'm going to type in negative 3 as my left boundary. And you can see that it's looking over here. And then I'm going to do my right boundary, which I can just say is 0. So now I'm between these 2, and my guess, I thought it was negative 2. Enter it in, and I can see that x is equal to 2.2. 3 significant figures makes 7. Repeat the same scenario on the other side. I'm going to go 0. My left-hand boundary I'm going to say is negative 5. My right-hand boundary I'm going to say is negative 3 this time. And you can see these lines here, that means the answer is somewhere in between them. That's why we put left bound and right bound. And then I'm going to go negative 4 as my guess. And I can see that x is equal to negative 3.73, and this one is also negative 2.2. And that is probably the easiest way to solve this quadratic. So we have polysimultaneous, we have graphing quadratics.